Homogeneity of an equation. How to check homogeneity of an equation in physics. There are base SI units for describing the 7 base quantities, and these are all the 7 basic quantities, and the unit of length meter, mass kilogram, time seconds, and temperature Kelvin, ampere, current, amount of substances mole, luminous intensity candela. From these 7 base units, other units can be obtained by performing different operations like multiplication, division, with the base units to describe derived quantities. These other units are called derived units. Example: area, length into breadth. It can be written like this: length multiplied by length. It is the base quantity. What is the unit of length? Meter. Meter. Meter square. So the unit of area is meter square. As we are deriving this unit from the basic quantity, area is known as derived quantity and meter square is known as derived unit. Distance. Distance is known as length from the base quantity divided by time is another base quantity. The unit of length meter, division unit of time seconds. It can be written like this: meter per second, and this also a derived unit because this formula of speed formula, length over time, is derived from the base quantity. Length is a base quantity, time is another base quantity. We get help from the base quantity to derive the formula of speed, so it is known as derived quantity. Speed is a derived quantity and meter per second is the derived unit. Units of some derived quantities are given special names. Force. First write the formula of force: mass multiplied by acceleration. Unit of mass kilogram. Unit of acceleration meter per second square. It has another special name. The unit of force is known as Newton. So the kilogram, meter per second square and Newton, these are all the units of force, and it is a derived unit because we derive these quantities from the basic quantity. Frequency. First write the formula of frequency: 1 over time. Unit of 1 is a constant, there is no unit for the constant, and unit of time is seconds. It can be written like this: per second. It has a special name, it is called hertz. So it has a 2 units. Hertz equivalent unit is s power minus 1. Newton, its equivalent unit is kilogram meter per second square. How would you check the homogeneity of an equation? The homogeneity of an equation means that the units of both sides of the equation should be the same. Now here is an equation. Kinetic energy is equal half mv square. Here we have the left hand side of equation and here the right hand side of equation. The unit of energy and the unit of mass velocity square we have to find, and the final answer for the energy and mass velocity square will be equal. If it is equal, then this equation is homogeneity. In this way we can check the homogeneity of an equation. Example, here we have two equations. V is equal A eta simple A per rho. V is here speed, A is a constant which does not have any unit. Eta, viscosity. A is known as width. It's not acceleration. It's given as width. Rho, it is a density. This formula you can see in fluid mechanics, and we have to check if it is homogeneous or not. What is homogeneous? As I said before, the unit in the left hand side should be equal to the unit in the right hand side. If it is not equal, it is inhomogeneous. If it is equal, it is called homogeneous. So first we resolve the units of these quantities. And first, this constant does not have any unit, so we can neglect. And the unit of speed, meter per second. Viscosity, the unit of viscosity is Pascal second. What is Pascal? It is the unit of pressure. We can again resolve the pressure into its equivalent unit. How to resolve it? We should know the formula, force over area. So what is force formula? Again we have to resolve the unit of force. We have to resolve some more in detail because the unit of force is Newton, unit of area is meter square. Still we have to resolve it into the base units. We have to give it in the base units. So write the formula of force again, mass multiplied by acceleration over area. So here we know mass kilogram, the acceleration velocity over time, meter per second over second. So if you take this up, it becomes meter per second square. So I write here meter per second square divided by meter square. If you bring this to the numerator, it becomes -2. Now if you resolve this again, it becomes kilogram, meter power 1 and meter to the power -2. If you simplify this, you get meter to the power minus 1. And what is the remaining? Second to the power minus 2. Now this one, pressure unit is Pascal. So the Pascal is equal to kilogram meter to the power minus 1 second to the power minus 2. I substitute this value here in the place of Pascal. So kilogram meter to the power minus 1 second to the power minus 2, and here the seconds. Again you can simplify this. Kilogram meter to the power minus 1, you simplify this 2, assume here is 1, so it becomes second to the power minus 1. So it is the unit of viscosity. Unit of width is meter, and density, write the unit of formula of density, mass divided by volume, mass divided by length multiply length multiply length, unit of mass kilogram, length meter, so it becomes meter cube, kilogram if you take into the numerator, kilogram per meter cube. So these are all the units, 1, number 2, 3 and 4. Now we are going to substitute and simplify and check if both sides, the units of both sides, left and right hand sides, are equal or not. If it is not equal, it is inhomogeneous. If it is equal, it is homogeneous. So right here the unit of speed we already found, meter per second. It's a constant, there is no unit, so no need to care about the constant. And here is eta, it's a viscosity we already found, kilogram per meter per second. Now it is done. And now for the width, here it is written meter, is a division, rho, kilogram per meter cube. Now we have to bring this denominator into the numerator, so the signs, positive negative signs, will be changed, reversed. So it will be like this, kilogram, write the numerator as it is, and now I am going to write kilogram to the numerator, it becomes -1, and meter cube, meter power minus 3 becomes meter cube. Now you can simplify, +1 -1 is cancelled, here positive negative is cancelled, so remaining meter cube per second, here meter per second. So it is not equal. This equation is known as inhomogeneous. Inhomogeneous. Now let's check here. Speed, meter per second. B is a constant, it has not a unit. Eta, same unit, kilogram per meter per second. Here is a division, right here division, it's a width, meter multiply by density, kilogram per meter cube. It is written here, width and density. Now bring all the denominator into the numerator and write the numerator as it is. Meter, it becomes per meter. Kilogram, it changes its sign. Meter to the power minus 3 become positive 3. Now you can cancel. Positive 1, negative 1 is cancelled, and here minus 1 it becomes minus 2. This become the same, and meter cube. Again you can simplify. Minus 2 positive 3 will be positive 1 and remaining second per second. But in the other side, meter per second. Left side and the right side, the units are the same, so it is homogeneous.